Okay, we have finished up the design portion of class, and we are now getting ready to move into parametric design. What is parametric design? Everything we've done so far in class, when we're sketching it out, we have been, our dimensions, we've been putting in numeric values, okay? And those numeric values are hard-coded. Okay, so we're putting in a value. The slang for that is hard coding your dimension. All right. In parametric design, we're going to start plugging in variables in place of values. And we're going to have a table of variables. And we can go into that table and change the values associated with the variable, and it will update our design. Let's go look at what I'm talking about. All right. Here's the Lego brick that we have done. And let's look at this Lego brick. Let's go back and look at our first sketch. Let's edit the sketch. All right, and there is our design. And we have hard-coded values in there. Okay, 31.8 millimeters, 15.8 millimeters. When we extruded that, it was to 9.6 millimeters. Finish sketch. Edit the feature. Go to the home position, and you'll see the extrusion was 9.6 millimeters. Now we've messed around. When we did the bottom connectors, we took the height of the brick and subtracted the shell, the wall width, from the height of the brick to get the height of the the bottom connector. So we started to look at formulas, okay, letting it do the calculation for us. Now, we'll finish that up. There's our brick. Parametric design is simply meaning that we will use the formula. We will use formulas, or we will assign a value to a particular dimension, which is a variable. Everybody had algebra now, know what variable is, okay? And that variable can be modified in a variable table. But we would, instead of setting this length here to 31.8 millimeters, we would create a variable table, and we would define a variable length. And we would set that variable to be either a value, which could be 31.8 millimeters, or formula. Okay, you can build formulas in. In this particular case, that length will end up being a formula. The length will be dictated by the number of top connectors across the top, and then adding in the distance each end connector will be from the edge. Okay? So that formula or value that it produces will change when we alter the number of top connectors in a row. That way, when we decide we only want our brick to be, let's say 2 rows of 2, the length will automatically alter. Let's go to this example. I'll show you what I'm talking about. So here's basically the same Lego brick, but this Lego brick's been built with a parameter table. So let's go to change parameters. Notice my length. There's the formula for my length, the formula for my width. Here's my rows of top connectors, the number of top connectors in a row, the number. Okay, yeah, this is the number of rows. Looks backwards to me. Okay, so let's change this to 2. Click OK. My brick changes. The length of my brick changes because I set that formula. I've only got one bottom connector now versus the 3. Let's go back and change it back. And there it is back. Okay. So, why would we worry about parametric design? Why is that important? Let's say you were manufacturing Legos. Every time you came up with a new brick, would you want to create a new design? Or would you rather create one design and go in and say, I need 10,000 of 8 by 4. Click OK. There it is. Flip it. Bottom connectors are all good. Print it. Send them to print. Okay, one design works for all. All right, that is kind of an overview. I don't want appearance of what parametric design is. Instead of working with fit, there we go. Instead of hard coding everything and making one design that is simple, you're using parameters, variables. You're assigning those parameters values, or you're doing it by giving them value or by using a formula to calculate the value for that particular parameter variable. And when you alter certain variables, the design will change to reflect the changes made in the variables. All right, that's enough here. That's an overview, and I'll see you in class.